Right. So here's just in response to a student question. This is what it is. This putty key generator is one of these systems where it says generate some randomness by moving your mouse over the blank area. And you have to do this for a couple of minutes for it to get enough randomness to generate a key. There's quite a few systems like that. It has to get random values somewhere, and getting you to move your mouse is one way to do that. Anyway, let's get back to the slides, which are here. All right. So then there's token handling. So SSL will prevent people from just sniffing packets next to you in a wireless network and getting the key. But if I have a trick like cross-site scripting, then I'll put code on the page, which when your browser renders, it will cause your browser to deliberately send the key to somebody else, and then that will overcome the encryption. So this is a common issue where people think the token is not vulnerable because their platform uses the modern version of SSL, but that doesn't mean it can't be stolen. All right. If you transmit it without encryption, of course, then anybody nearby can steal it. Anybody close to a wireless network you're using, or at your ISP or at the ISP of the other end, packets pass through a bunch of servers on the way out. So now, if I can steal your password, I might not have enough information. For example, that's the whole point of two-factor authentication, which is extremely powerful. You need to have like a USB key plus the password. So if I steal the password, but I don't have the USB key, I can't get in. But even if that's the case, after you log in, you're going to need a session token. And that is probably not two-factor. So stealing a session token can be more powerful than stealing your password. And you will not get a warning like you might if I start using your password from another location. So I found stealing session tokens can be very effective. This is what happened to me, of course. Until 2012, Gmail used HTTPS when you're logging in to protect your password, but after that it did not protect your session token, so somebody that's able to intercept your traffic during a session can impersonate you and get in. Another thing people do often is when you first connect to the server, it assigns you a token right away, and then when you log in, it continues to use the same token and just promotes it to a higher value where now you're logged in. So that's not good because the original page might not be as well protected. It's considered a best practice to always assign a new token every time you log in, so that the logged in tokens are completely separate from the unlogged in tokens. And if you don't use HTTPS on every page, which is what most people are now switching to, then if I can move back or forward somehow to a page that doesn't use HTTPS, then a token will, for that one request, be sent unencrypted. You say how they pretend you by having copy token. Well, you could do it in Burp. All you have to do is make the request. If you go into Burp, you'll see the, let me go back to this page here. Way back at the start, we had an example of this, finding what part of the token mattered. There we are. So here I am sending a request to Amazon, and it turns out that the only thing I need to know is this X main number. So if I can sniff your traffic with Wireshark or something by sitting next to you in a coffee house, and I can get your number, I could just paste that number in here. And then I could send requests to Amazon and it would interpret me as being you. You can do it right in Burp. You can also do it with a variety of other tools, and the tool, there used to be a thing called Fire Sheep that would do this automatically. In around 2011, everybody used this system that Google used of unencrypted tokens. Facebook did, and Twitter, and everybody. So you could just turn on Firesheep in a coffee house, and it would just steal tokens from everybody in the room, and you could just click on that and be right in their Facebook, right in their Twitter. It was ridiculous. You could just get in anybody's session anytime. And you can totally do it in Burp. You can do it with any tool that just lets you change the cookie. You can even put like a cookie editor extension on your browser, and then you can change the cookie in your browser. So you're now in somebody else's session. It's really a pretty simple attack. And that's why it's not that easy anymore, because now almost everybody is moving to HTTPS. And that's the main reason. If you move to HTTPS, then I can't see other people's traffic and I can't steal the cookies out of it. But that didn't really catch on until 2012, 2013 or so. It's amazing how long they kept sending unencrypted session cookies. All right. Anyway, so SSL strip, how do you edit cookies? You do it with a browser extension. Yeah, cookie editor extension is the easy way. Something like Hackbar, Edit My Cookie is one, and of course Burp. Burp is the most professional tool to do it, but you can do it with, just like you edit any header. But yeah, there are just cookie editing extensions you can put in your browser. That's the way I did it when I was just a beginner, before I wasn't much good at Burp. Burp is the cool way to do it. But yeah, it's a very simple activity. Anyway, so SSL strip is, by the way, essentially, well, SSL strip is a particular tool which is even more drastic than what Burp does. What SSL does is I get in the middle of your traffic, and then when you load the page, like Gmail, SSL strip is a proxy server, and when you get the page, it hands you an HTTP page into your browser instead of an HTTPS page. So it looks the same, and you can log in, but the data is in fact being sent unencrypted. It will get re-encrypted at the proxy, so Gmail will not know this has happened. Now, this is really deadly, and been known for quite a while, and that's why modern browsers know for like the top 100 or 1,000 websites whether they should be secure or not. So if you try to send them an unencrypted Gmail page, they won't fall for it anymore. But if you have a less popular site, it might work. And this is why mixed content pages are so dangerous. This was very popular by banking until about 8 years ago. You would have a page that was HTTP, but the login button would be HTTPS. And that is a really bad idea, because there's no way you can tell that I don't show you a fake banking page, like a phishing page, with an HTTP button. There was no way for you to see it. So now, like I say, the cure for all this is for everybody to just use 100% HTTPS all the time. That solves a whole ton of these problems, and that's where most people have gone, and that's because Google did it first. Around 2012, Google just went to 100% HTTPS, and they exploded the myth that that would be really expensive or difficult. And pretty much everybody's moved that way. In fact, it's pretty hard to find HTTP pages anymore. So, if your app uses HTTPS for every page, then I can still send you a link to trick you into clicking on a link that's actually using HTTP. And if they didn't put the secure flag on the cookie, then the browser will send it to this HTTP link, which I can intercept. So here's the game. Just watch your URL in every session token and notice when it moves from HTTP to HTTPS. If it does that, that's a potential vulnerability. And so you can see it in Burp. Like, here's my page doing many HTTP requests because this is one of my unsafe pages. But you can just watch here and see when the HTTP changes to HTTPS. Now, what you ought to be doing in a modern page is you should set the secure flag. When you set the cookie, you can set the secure flag, and then the browser will not send it ever over HTTP, and that is the right thing to do. So here, when you set the cookie, username, date of expiry, and here's where you set whether it's going to be secure or HTTP only. You can specify that. And so you see that here, secure equals false, HTTP only equals false. So this is how you do it in PHP, and each language has a way to do it. So then the browser will be told not to distribute that page another way, not to distribute that cookie another way. So I had a page to demonstrate this. I don't think I'll bother. Now we're using the Burp stuff. But anyway, I was able to do this. And if you downgrade to an HTTP session, it forgets who you are because it doesn't send the cookie anymore, which is what should happen. Anyway. So, all right. Anyway, by the way, HTTP only means you cannot send the cookie through JavaScript. And that means you can't get it with cross-site scripting. So these two flags should be set on cookies. It's a very good practice. Another thing, which is a modern solution, is this, strict transport security. This is a header you put on the header part of your page that's served up to the viewers, and it warns the browser that this page should be secure. And it will therefore prevent any communication being sent over HTTP anymore. So this is a way to tell your browser, I am a secure page and I never am an insecure page. So even if somebody somehow tells you to click on a link that's like http mycompany.com, your browser will know not to ever do that, but to always use HTTPS. So this is a way to inform browsers that you are a modern website that does not use HTTP anymore. Because for a long time, browsers had a tradition. You would go type in like yahoo.com, and the browser would first try http yahoo.com, and then it would only try HTTPS later. So if I just tell you a URL, you might end up at the insecure version of a page. And if you put a strict transport security header on your browser, on your web page, then after the first time any browser sees your website, it will never try HTTP anymore, and that's what you want. All right, and now this is pretty popular. This has been recommended for years, and I checked, and as of now we're up in 2021. Now it's up to 15% of websites are now using the strict transport security header. So it's gradually catching on as everybody switches to HTTPS and they abandon HTTP. All right, and so another thing that we talked about before is you should have, once you have anything that is confidential, like a session cookie, you should not put it in the use visible part of the URL. But in fact, you can Google for in URL JSession ID, and I looked around and I found the Centers for Disease Control does this. There's a JSession ID right up there. Just find a bunch of these, and then I tried looking for PHP session IDs. See, this one I think is another. Yeah, these are also JSession ID. Some kind of World Health Organization has a JSession ID right up here where it shouldn't be. So does these guys, Junior Achievement. And I found some PHP ones too. This All Staffing Healthcare has got a PHP session ID right up there in the URL. And this Hawk Count, counting hawks, bird, again, I have a PHP session ID right up there. All those are breaking best practices, and the problem is that session ID will now appear in error logs and favorites and other places. Bigfollows.com. I guess that's spam in my Twitch. If I knew how, I'd figure out how to kick them out. Anyway, yeah, the problem is sending session ID and GET requests. Yeah, well, you can send it in GET requests, but it should be in the header as a cookie. It should not be right there in the URL. You should never put anything confidential up here in a URL because it's not handled very well at the other end. So that's the case. If you put them in there, it'll show up all these places in the logs of proxy servers and refer. There's another really dangerous one. If you go to a page like this with your session ID there, and then you just go to a different site, it'll appear in the referrer. It'll appear as where you came from. So I could just send you a link by chat message or something, say click on this link, and it'll send it to me. And when you go to some other page, it'll be up here in the referrer with the session. That's why it should not be in the URL like that. It's a poor practice. So I mean, you could try telling these people, but I highly doubt anybody would care. It's like cross-site scripting. I don't think anybody would pay you a bounty for that or anything, but it is a bad practice. All right, that's a referrer attack. All right. And so another thing some people let you do is they let you have two sessions open at the same time, using the same token from two machines, and that's not a good idea either. And that's true of about half the websites I've tried. So here's another one. They send you a token like this, but if you just decode it with base 64, you'll see this, but it will let me use the same token with a different username. So this token is not really a session ID tied to that user. It's just like proves that you're logged in, and if I change this name, somebody else is now logged in. So really, this is just a Boolean value, logged in or not an actual session token that is keeping track of who I am on the server. All right, and if you don't log out, in about half the websites I tried a few years ago, I did a big project on this, when you log out, they don't invalidate the session on the server. They just delete the cookie in your browser. So if I stole the cookie, I can just keep on using it, even though you have logged out. This is quite common. I did a whole chest of these, and I got I found dozens of sites that had this problem after I saw it was true of Microsoft Office Online at the time, the Office 365, and many other services had this flaw, like American Express and Chase. Anyway, so if you steal a cookie, then I can get in, or if session fixation would be if it takes the cookie before you log in, then I can feed you a request that contains a cookie, and when you log in, the same cookie will still be used, and since I gave you the cookie value, I know who you are. That's session fixation. Yeah, and you found it in another medical app. Yeah, it's a good point. Yeah. So that's good. That's why it's good to do a security audit of an app and write it up. You may not want to bother telling the company, depending on what you're finding and whether you're willing to take some risk of them retaliating, but it's very good practice to go through an app and find the flaws. And then there's cross-site request forgery. This is where I trick you into making another request and your browser sends the cookie along. So I can put a link on my page that goes to Amazon and orders my book. And if you're already logged into Amazon, clicking that link, your browser might send the Amazon cookie in and authenticate. That's cross-site request forgery. So when you set a cookie, you can specify how big the subdomain is. So if I set a cookie by games.samsclass.info, it'll be sent to that URL. It'll also be sent to things that end in that URL, like foo.games.samsclass.info, but it will not be sent to samsclass.info. It's tied to this URL and subdomains based on that URL. So, for example, if I'm at foo.wa.com and I set this, it'll send it to all. If I set the domain here specifically to the root domain, waapp.com, then all subdomains will go there. Now, I could set a cookie for a more limited one. By the way, you cannot set a cookie to just .com or anything. That's called the same origin policy. This is one of the big security features of browsers, and it turns out to be pretty weak. So if I had blogs.com and I set a cookie for each user, then if I made them so they were at the level of blogs.com, then users could steal tokens of other people. So what's better is to use a different domain name for the main app. So the main app would be www.blogs.com, and each user would be like joe.blogs.com and sue.blogs.com. So the cookies used here to log into this thing as a whole would not be sent here. That's the kind of thing that you can think about. And you can also specify it here with the path where you specify this, and it will limit what other domains are accepted as part of this domain. All right. Anyway, so if you want to secure session management, you got to generate strong tokens with some way so they can't be guessed, protect them through their life cycle. And so the best thing is just have a strong random number that's long enough that people can't guess somebody else's number or predict somebody else's number. And if they try to change anything, it will just become invalid. There should be no meaning or structure. It should not encrypt any meaningful data. It should just be a random number. And you have to get sure it's a random number generator that really is unpredictable. So you have to have some source of entropy, like the time of the request, the IP address, and so on, or some kind of secret known only to the server. That's one technique to do it. So transmit over HTTPS with secure and HTTP only, so the browser will never send it unencrypted, and it will only send it for HTTP requests, not for JavaScript requests. Those are good things. Don't put it somewhere like in the URL where it's going to end up having extra copies of it stored all over the place. And when user logs out, that should invalidate the token on the server, so that if somebody else has that token, they can't get in anymore. They have to do the login process again after they log out. The session should expire after some period of inactivity. You shouldn't allow people to have multiple sessions with the same token from different sources. This is so on. You restrict the path for session cookies. Don't accept tokens submitted by unrecognized users. The usual stuff. And two-factor authentication is very good. Then if people steal passwords, they don't get in. Using hidden fields is better than session cookies if you can do it. That's what you use for anti-CSRF tokens. They're not sent in every request. create a fresh session with a new token after every authentication. And you can make a per-page token every time they go to a page, and this prevents pages being used out of order like we talked about. This is an anti-CSRF technique. And here's per-page tokens used in a banking application. I've got some hidden fields, screen token name, so it's automatically put in by the web page you view when you go to the next page, so it doesn't irritate the authorized user. But if somebody else is trying to replay a token, they won't know this hidden value, so it won't take it. This is why I say every time I go to burp repeater and I try repeating a request and it works, I know they have not implemented these anti-CSRF tokens, and that's a failure of best practice. So in general, when people send in invalid things, you should be regarding that as a security flaw, not just continuing to use the remaining good data. You should block the IP address, put them on a list of known attackers, something like that, kick them out, terminate their session because, they're an evil attacker trying to get in. If they generate traffic like that, they're not a real user using your page as intended. All right. So let's take a look at the last cahoots. All right, good. Let's go. All right, so what does HTTPS prevent? Yep, you can't sniff the wireless traffic. You can sniff it, but it will be encrypted with a key you don't have, so you won't be able to read the data inside there. All right, what defense prevents users from clicking through a warning, an HTTPS warning? That's good. I didn't mention it, but it's true of HSTS. That tells it I've got real HTTPS with a real valid certificate. Do not accept broken HTTPS to see this web page. All right. What defense protects cookies from JavaScript? Yep, that's HTTP only. All right. And what should a logout do? That's it. It should really end the session so nobody can use that token anymore, but a lot of them just delete the cookie from the browser, which is not the same thing. All right, what type of session token is not sent on every request? That's hidden fields. That's when the developer marks your page with a number, and they can then make sure when they see another request that came from that page, and other people viewing it see a different number. So it's a much more controlled, limited way to mark your browser than a cookie, which would just be remembered and sent back in every future request. All right, what happens if you receive a request with a modified hidden form field? What should you do? Yeah, terminate the session. They're now obviously a hacker. They're not a legitimate user. All right. All right, I found out who Clickers is. Good. And I know who K is. And there's Kunal. Wins every time. All right, good. So those are the winners. Stop recording this one.